They have given by x1, x2, x3 and xn. So we may have different numbers of constraints for a particular task. How to find out the solution using the graphical method of linear programming. The region which satisfy all those conditions is considered as the feasible region, and we will mark the feasible region. We will find the corner points, then we will substitute the value of x and y in the optimal solution. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here we are learning about linear programming problems. In our previous session, we have learned why linear programming problems are widely used in the field of business, industries, especially in the field of commerce. And we have also studied how to formulate any situation into linear inequalities. So here in this session, we are going to solve those linear inequalities and found the optimal solution for the given task. So what do you mean by a general linear programming problem here? So general linear programming problem. A problem is linear programming is formulated. It is formulated and we have learned how to formulate it already mathematically by first identifying a set of decision variables. We are just finding the decision variables first. It may be from x1 to xn. That means you may have n number of dependent or decision variables which are subjected to certain linear constraint written in the form of inequalities. Inequalities I have already told, it may be less than or equal to, greater than or equal to, strictly less than or strictly greater than. So these decision variables are converted in terms of a linear equation here using less than or equal to, greater than or equal to, along with some constants here. So, and it depends on how many linear inequalities we may form according to the given condition. It may goes to m number of variables. Here b1, b2, b3, bm are all constant and they are all non-negative constraints which are given by x1 greater than 0, x2 greater than 0, x3 greater than 0, xn greater than 0. That means they are all positive integers. So the aim of this mathematical formulation is to optimize a linear expression. So optimize means finding the maximum or minimum value of the given linear expression. So, and this is usually given with the constraint C1, C2, Cn. So, this is called the objective function. The function which is expressed in terms of z is equal to ax plus by4, which is a simple expression. And if you have n number of terms, then you have n number of constant along with n number of terms in the powers of variables. So these are called as objective function. So here, what are this b1, b2, bn? They are all constant and they are all positive. That is, they are all non-negative constant. So they may be equal to 0 or greater than 0. And they are called constraints. They have given by x1, x2, x3 and xn. So we may have different numbers of constraints for a particular task. Now the aim of this mathematical formulation, what we have done previously in our session, that is used to find the optimal solution for the linear function, that is to optimize a linear expression. So what do you mean by optimization? Finding the maximum or minimum value, or when it comes to the field of industry or business, it is nothing but so finding the maximum profit with minimum cost. So that is nothing but optimization of a linear expression. So here z is equal to, we say z is equal to c1 x1 plus c2 x2 etc. till cn xn. Based on the number of constraint, you have n number of constant. Usually we can write z is equal to ax plus by form, only two linear variables x and y. So that is also a linear function. So the function z is called as objective function, and the optimization, that is nothing but the maximization or minimization of the objective function, is called general linear programming problem. Next, we come across the structure of linear programming problem. So what do you mean by structure? What are the terms we have in linear programming problem. The very first one, we have a general structure of linear programming model consists of three basic components or elements. What are the three basic components or elements? First one is objective function. Objective function simply in the form of ax plus by we write. We have already formulated it. So that is a z is called the objective function. So this is the function which is to be maximized or minimized in the problem. This function is always a linear function consisting of variables. It is denoted by z. Next is decision variables. So whatever the variables you have, if you take this as an example, the variable x and the variable y. So based on the values of x and y, the values of z also changes. So therefore they are called as decision variables. These are the variables which affect the value of the objective function. These variables are denoted by x1, x2, x3, etc., xn. Here I have written in the form of x and y. Next, we come across constraints. So what are these constraints? These are the conditions existing with regarding of the decision variables. These constraints will be in the form of linear inequalities. We have written many equations, for example, 2x plus 3y less than or equal to 100, 2x minus 3y greater than or equal to 50. All these expressions, that is for a particular task, we may have certain construct which we expressed it as a linear inequality. So those are called as constraints. Next, apart from this, we have different components in the linear programming problem also. What are they? The first one is feasible region. This is purely based on the graphical solution. So when we are going to try to find the solution of optimal function with the help of graphical solution, these are the terms where we come across. The first one is feasible region. While solving the linear programming problem by graphical method, every constraint is satisfied by a part of coordinate plane. The region of the Cartesian plane, which is the intersection of all these parts, thus representing the region which satisfy all the constraint, is called the feasible region. So when you are going to solve the linear constraints in a coordinate plane, you will get a straight line. So the intersection of all these straight line below or above the region where all the constraint satisfies the equation, that region is considered as the feasible region or the solution region. Next, we have a feasible solution. A solution which is a set of real values which satisfies all the constraints is called feasible solution. So the solution where all the constraints have the solution is called as the feasible solution. The next one is optimal solution. The solution for the objective function. So that is the feasible solution which achieves the objective on hand, that is either maximizes or minimizes the objective function. The case may be the optimal solution. It optimizes the objective. In the graphical method, the solution occurs at one of the corners of the feasible region. This is very important. So the solution of the optimal function occurs in one of the corners of the feasible region. Next, how to find out the solution using the graphical method of linear programming. So we have taken in the form of steps. So these are the following steps here. Step 1 says, represent the given problem in mathematical form. Formulate linear programming for the given problem. So that we have already done. Certain statement problem is given. We have to formulate all those optimal function in the form of a linear equation and linear inequalities. Step 2. Represent the given constraint as equal to xy. Consider each inequality as an equation. Plot each equation on the graph as which will geometrically represent a straight line. Even though we will get an inequality less than or equal to, greater than or equal to, we will take the equation in the form of a straight line equation. We will draw a straight line for the given linear inequality. Next, mark the region. So we have to mark those region If the inequality constraint corresponding to line is less than, then the region is below the line. So if you have less than or equal to symbol, that means if you have drawn any straight line in the coordinate plane, if you have less than, that means the solution region will be the positive region. You should know the positive because we are taking only the positive axis here. That's why I have written x greater than or equal to y greater than equal to 0 in our previous session. We are taking only the positive solution, that is x and y positive. So the region will be below the line if it is less than or equal to. And it will lie in the first quadrant as I said. Next, for the inequality greater than or equal to sign, the region will be above the line in the first quadrant. Again, if it is greater than or equal to, this complete region is considered as the solution for the linear inequation. And when you have two or more lines, with that case, the region which satisfy all those conditions is considered as the feasible region, and we will mark the feasible region. We will find the corner points, then we will substitute the value of x and y in the optimal solution. We will find the maximum and minimum value. So this is how we are going to draw or find the solution of a linear programming problem by graphical method. The step 4 says, measure the values of two decision variables x and y. Graphically, at each of the vertices of the feasible region, the values of x and y at one of the vertices represents the optimal solution. If my aim is to find the maximum value, so using these x and y value, we will find the maximum value of z. If not minimuming the value, same again using x and y value, we will try to put it in a table called corner point table and we will find the minimum value. Step 5, calculate the value of the objective function at the corner points. We may get the feasible region. After finding the feasible region, suppose for an instant, if two straight lines are drawn and if both are less than or equal to, this is the common region. After finding the common region, we will get 4 corner points. I'm just taking an example. So using those 4 corner points, substituting in the place of x and y in the optimal function, that is z, we can find the maximum or minimum value for the given task. Now let's try to solve some of the linear equations using graphical method, that is finding the solution of LPP. Solve the following linear programming problem using graphical method. So the maximize z is equal to 60x plus 15y. Subject to constraint x plus y less than or equal to 50, 3x plus y less than or equal to 90. So these two symbolizes the solution should be always in the first quadrant where x and y are positive. So first, let us consider these two equations. I will take is equal to 50. Even though they have given inequality, I will take it as equal to draw a straight line. So let us find the solution for this. I will take x and y values separately. So very simple problem is, I need 2 points to draw a straight line. So just find 2 points for each equation. If I put x is equal to 0 in this equation, y is equal to 50. If I put y is equal to 0, then x is 50. So for this line, the equations or the points, the solution may be always write in the form of x comma y. First x, then y. So the point will be 0 comma 50 and 50 comma 0. Let us try to plot this on a graph. So let me take this as 0, 20, 40, 60, 80, 100, 120, etc., which is x-axis and this is y-axis. I'll take this as again 20, 40, 60, 80, 100, etc. So now this is my graph which I have plotted. First, let me draw a line for this equation. So, my first point is 0, 50. So, it is in 0, 50, which is this point. Next point is 50, 0. So, somewhere here. So, I'll draw a line to join those 2 points here. Extend the line. Draw a straight line using the scale. So, what is the equation of this line? X plus y is equal to 50. So, this is the equation of the first constraint. The same steps we will do for this equation now. So, let me solve it. So, let me take x and y values as 0. First, I will take x is equal to 0. If I take x is equal to 0, then y is 90. If I take y is equal to 0 here, I will get 3x is equal to 90. Then x is equal to 30. So, the points are 0, 90 and 30, 0. So, let us plot the points once again. My first point is 0, 90. So, 0, 90. And the second one is 30, 0. So, 30 here, 0. So, this is the straight line I will get joining these 2 points. Extend the line. What is the equation of this line? 3x plus y is equal to 90. Now, observe the equation here. The first equation is less than or equal to. Less than or equal to means the solution region lies below the line. So, you have this region now. The solution will be below this line. Next, the second equation is also less than or equal to. That means it is again the below. That means this is the solution. But where is the intersection of those two regions? That is, this is the part where we are getting intersected. So, therefore, this is the region where both two are intersecting each other. So, now this is called the feasible region. Now, this is the feasible region. Observe the feasible region now. Now, we have 4 edges. This one. These are the 4 edges. Mark these points as, since this is origin, it is O. I'll take this as A. I'll take this as B. I'll take this as C. When you look at the graph properly, this point is actually what? 30, 0. This point is actually 0, 50. Now, when you look the intersection of the x value and y value, you will get the point B as 20, 30. So, this will be the actual point. Here, my diagram may differ, but when you draw it exactly on the graph paper, your point will be exactly 20 and 30. Now, these points are called as, this is 0, 0, the origin. These points are called as the corner points. Let us write the corner points in a table now. We will draw a table. So, this is called as corner point table. We will use the corner points to find the solution for a z. Now, here I'll write the corner points. And here my function z is equal to 60x plus 15y. So, let's write the corner points now. One is 0, 0. Next, A is 30, 0, B is 20, 30, and C is 0, 50. So, these are the points 0, 0, 30, 0, 20, 30, 0, 50. So, now let's substitute the value of x and y as 0 and 0 now. If you put x is equal to 0 and 0 here, the value is 0. Next is 30, 0, 60 into 30, which is 1800 plus 0. Because y is 0, so the value is now 1800. Next, we will take 60 into 20, that is 1200 plus 15 into 3, that is 450. So, which is equal to 1650. Next value we have 0. X is 0, so the first value is 0. Y is 50, that is 15 5s are 750. The value is 750. Now we have solved the corner point table. My aim is to maximize the function. So maximize means finding the maximum value at the given corner point. So look at the table now. So where you are finding the maximum value? Here, that is 1800 will be the maximum value. We write it using the capital M. Capital M means maximum value, small m means minimum value. Now the problem is to find out the maximum value for the given function. So therefore, the maximum value for Z is 1800 at the point A 30, 0. So this will be my optimal solution, and this is the optimal point for which I get the maximum solution. So I'll write here Z max is equal to 1800 at the point 30, 0. So this is how we are going to find. So this can be taken in terms of statement also. Suppose you are selling any two products. One product is X and another product is Y. Suppose the cost of X product is 60, the cost of Y product is 50, then how you will sell those products to get the maximum profit? So you can sell 30 products of the first kind, so you will get the maximum product instead of selling nothing of the second product. So this is how we can find the maximum or minimum value using LPP. Let's look at the second problem now. Maximize Z is equal to 5x plus 3y subject to constraint 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10. Again, the solution region lies in the first quadrant. First, let us solve the linear inequalities. So we have two linear inequalities here. So let me take x and y value here. So let me put x is equal to 0. X is equal to 0, 5y is 15. That means y is equal to 3. So the point is 0, 3. And let's see the next point. I'll put y is equal to 0. 3x is equal to 15. That means 5. So the second point is 5, 0. Let's see for the second equation now. xy value. So put x is equal to 0, 2y is equal to 10 means it is 5. So the point is 0, 5. And let's see the next point. So if I put y is equal to 0, then 5x is equal to 10 implies x is equal to 2. So the point is 2, 0. Now let's draw the graph. So origin 0, 0 and x value, y value. So let's see now. 1, 2, 3, 4, 5, 6, 7. The values of x and y axis based on the points which we have considered. Previously I have taken it as 20, 30 to draw the graph. Similarly here the values are in terms of 0, 1, 2, 3. So I have taken 0, 1, 2, 3. So 1, 2, 3, 4, 5, 6. Let's draw the first line. The point is 0, 3, 0, 3 and 5, 0. So this is the line. So draw using scale in your graph. What is the equation of this line? Here you should write the equality 3x plus 5y equal to 15. Next one. So 5x plus 2y line now. So one is 0, 5 again. So 0, 5 and 2, 0. This is the line. Can extend the line. What is the equation of this line? This is 5x plus 2y is equal to 10. Now clearly you observe here both are less than or equal to. That means the solution lie below the region. But where does the region intersect for both the constraint? So this is the region. You can observe. So for this line also the solution region will be below the line. For this line also the solution will be below the line. But where does the two lines intersect? In this region. So this is the feasible region. Now we have the points corner points. Let's look at the corner points. We have 0.1, 0.2, 0.3, 0.4. Origin will be always the corner point. So this point is 2, 0. This point is 0, 3. This will be the intersection of y and x values. So you may get some decimal points here, but when you convert it into fraction, the value will be 20 by 19, 45 by 19. So you can verify through the graph. Now let's try to use this corner points in the corner point table. Let's draw a table here, corner point table. I'm here using corner points. And here we have the equation z is equal to 5x plus 3y. Let's write the corner points. Origin is 0, 0. Next, I'll take this as A, B and C. So A is 2, 0. B is 20 by 19, 45 by 19. And C is 0, 3. Substitute the value 0, 0. So the first one is 0. The second one is 5 2s are 10 plus 0. The answer is 10. The third one, when you solve, you will get the value as 235 by 19. So multiply it is, you will get it as 100 plus 135 divided by 19, which is 235 by 19. Next is x is 0, y is 9, 3 3s are 9. So look at the value now. The maximum value you may get, this will be more than 10 exactly. So this will be your Z max. Which is the point you are getting the Z max? This is the point. So therefore, the maximum value of Z is 235 divided by 19 at the point 20 by 19, 45 by 19. So this is the solution. So the next question. Minimize z is equal to 3x plus 5y subject to x plus 3y greater than or equal to 3, x plus y greater than or equal to 2. Again, both are in first quadrant. Let's solve the equation here. So let's put x and y. If I put x is equal to 0, y is 1. If I put y is equal to 0, x is 3. So the points are 0, 1, 3, 0. Next point, simple, x, y, 0 you put, x 0 means y 2, y 0 means x 2. So the points are 0, 2 and 2, 0. Let's plot this in graph, x axis, y axis, origin which is 0, 0. Next we have 1, 2, 3, 4. 1, 2, 3, 4. Similarly 1, 2, 3, 4. Let's see the point. First one is 0, 1 here. Next is 3, 0 here. So the straight line joining these 2 points. What is the equation of this line? X plus 3y is equal to 3. Next point. One is 0, 2, another one is 2, 0. So this is the point. What is the equation of this line? X plus y is equal to 2. Now as here in the inequality, you have greater than or equal to. That means the solution of the first line also lies above the line. The solution of the second line also will be above the line. But where does the two line intersect? So you can see clearly this is the solution where both the region intersect each other. And the solution is purely in the first quadrant because they have already said both x and y values will be clearly above the region. And solution region only lies in the first quadrant. Now look here. So this is the solution region for both the linear inequalities. Find the corner point now. What are the corner points here? This is the point. This is one more point. This is one more point. Write the values. So you can take this as A, whose point is clearly you can write this as 0, 2. And here the point, here you can see here, this is 3, 0. And if you try to plot this using the graph, the value will be 1.5, 0.5. This is the value. Let's substitute this in the corner table now. So we have corner points in the optimal function. Corner points. What is my optimal function? Z is equal to 3x plus 5y. Z is equal to 3x plus 5y. So write the corner points. One is 0, 2, A 0, 2, B 1.5, 0.5, C is 3, 0. Let's substitute the solutions now. If you put x is 0, then 3 into 0, 0, 5 into 2 is 10. 3 into 1.5, 4.5, 0.5 plus 2.5, so the value is 7. Next, 3 3s are 9, 5 zeros are 0, the value is 9. My aim is to find the minimum value. So where is my minimum value? So this is 7 is the minimum value at the point 1.5, 0, 5. So therefore, Z is minimum, whose value is 7 at the point 1.5, 0, 5. So this is how we are going to find the minimum value. Next question. Maximize Z is equal to 2x plus 3y subject to constraint x plus y less than or equal to 400. 2x plus y less than or equal to 400. X, y are greater than 0 means first quadrant again. So let's solve this. Clearly we will write x value, y value. X is 0, y is 400. Y is 0, x is 400. Done with the points. Second equation, x and y. Again, if you put x is equal to 0, y is 400. If you put y is equal to 0, 2x is 400, that means x is 200. So you can write the points. One is 0, 400 and 400, 0. Another one is again 0, 400 and 200, 0. Let's plot this in a graph. So since the value are in 100, I'll take the units in terms of 100. 0, 100, 200, 300, 400, 500. Similarly, 100, 200, 300, 400, 500. So y value x axis. My first point for the first line is 0, 400. 400, 0. So this is the line. Extend the line. What is the equation of this line? X plus y is equal to 400. For the next line, again the point is 0, 400 and we have 200, 0. So this is the straight line which passes through this. What is the equation of this line? 2x plus y equal to 400. Now observe the inequality, both are less than or equal to. Less than or equal to means the region lies below the lines. So this is the region which is a feasible region for both two constraints. So you can see both two intersects at this region. So this is our feasible region now. When feasible region is found, first mark the corner points. So what are the corner points? One is origin 0, 0. The second one is 200, 0. The third one is 0, 400. So let me mark this as O. I'll take this as A. I'll take this as B. Now let's substitute this through corner point table. So first is corner points and Z is equal to 2x plus 3y. What are the corner points we got? 0, 0, A 200, 0, B 0, 400. Let's substitute this value. Both are 0, so Z becomes 0. X is 200, 2 to 400, it becomes plus 0. So the answer is 400. Next, B is 0. So 2 4s, 3 into 4, that is 0 plus 12, 1200. So the value is 1200. So therefore, Z has a maximum value of 1200 at the point 0, 400. So this is the optimal solution for the given LPP. So now you can observe the value we got is 1200. So therefore, Z has a maximum value of 1200 at the point 0, 400. So this is the optimal solution for the given LPP. We'll continue in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.